Yeah, so we are going to start with designing the dog behaviors. So how are we going to design the set of classes that implement the same fly and quack behaviors? But yeah, so we'd like to keep things flexible. After all, it was the inflexibility in the duck behaviors that got us into trouble in the first place. And we know that we want to assign behaviors to the instances of duck. For example, we might want to instantiate a new mallet duck instance and initialize it with specific type of flying behavior. And while we are there, why not make sure that we can change the behavior of a duck dynamically? In other words, we should be able to include behavior setter methods in duck classes so that we can, say, change the mallet duck's flying behavior at runtime. So from now on, the duck behaviors will live in separate class, a class that implements a particular behavior interface. That way, the duck class won't need to know any of the implementation details for their own behaviors. So for example, we are going to have an interface, let's say a fly behavior that is going to have a fly method. And then we are going to have different classes, for example, flying with wings and flying away, that will implement their own fly method and inherit from the fly behavior interface. So given these goals, let's look at our second design principle. Design principle says that program to an interface, not an implementation. So we'll use an interface to represent each behavior, for instance, fly behavior and quick behavior, and each implementation of a behavior will implement one of these interfaces. So this time it won't be the duck class that will implement the flying and quacking interfaces. Instead, we'll make a set of classes whose entire reason for living is to represent a behavior, for example, squeaking. And it's the behavior class rather than the duck class that will implement the behavior interface. This is in contrast to the ways we were doing things before, where a behavior either came from the concrete implementation in the superclass doc or by providing a specialized implementation in the subclass itself. In both cases, we were relying on an implementation. We were locked into that specific implementation, and there was no room for changing out the behavior other than writing more code. With our new design, the duck subclasses will use a behavior represented by an interface, fly behavior, and quick behavior, so that the actual implementation of behavior, in other words, the specific concrete behavior coded in the class that implements the fly behavior and quack behavior, won't be locked into the duck subclass. So, program to an interface. I don't see why you have to use an interface for fly behavior. You can do the same thing with an abstract superclass. Isn't that the whole point to use polymorphism? Program to an interface really means program to a supertype. The word interface is overloaded here. There's the concept of interface, but there's also the Java construct interface. You can program to an interface without having to actually use a Java interface. The point is to exploit polymorphism by programming to a supertype so that actual runtime object isn't locked into the code. And we could rephrase program to a supertype as the declared type of the variables should be a supertype, usually an abstract class or an interface, so that the objects assigned to those variables of can be of any concrete implementation of the supertype, which means the class declaring them doesn't have to know about the actual object types. This is probably old news to you, but just to make sure we are all saying the same thing, here's a simple example of using a polymorphic type. Imagine an abstract class animal with two concrete implementations, dog and cat. Programming to an implementation would be dog d is equals to new dog, declaring a variable d as type dog. A concrete implementation of animal forces us to code a concrete implementation. So animal is a abstract supertype, could be an abstract class or an interface, and dog and cat are the concrete implementations of the interface or the abstract class. But programming to an interface or supertype would be animal is equals to new dog. We know it's a dog, but we can now use the animal reference polymorphically. And then we can use animal.makeSound, which apparently we'll call this because this is an overridden method. So even better, rather than hard coding the instantiation of the subtype like new dog into the code, assign the concrete implementation object at runtime. So A is equals to get animal and A makes sound. So we don't know what the actual animal subtype is. All we care about is that it knows how to respond to make sound. Implementing the duck behaviors. So here we have two interfaces, fly behavior and quick behavior, along with the corresponding classes that implements each concrete behavior. So we have a fly behavior, which is an interface that all flying classes implement. All new flying classes just need to implement the fly method. So we have the fly behavior, which has a fly method, and fly with wings and fly no way are two classes that are implementing the fly method. So here's the implementation of flying for all ducks that have wings, and here's the implementation for all the ducks that can't fly. Similarly, we have quack behavior. We have an interface that includes a quack method that needs to be implemented. So we have a quack behavior interface that has a quack method, and then we have three classes called quack, squeak, and mute quack that implements quack method in their own ways. So quacks that really quack, quack that squeak, and quacks that make no sound at all. With this design, other types of objects can reuse our fly and quack behaviors because these behaviors are no longer hidden away in our duck classes. And we can add new behaviors without modifying any of our existing behavior classes or touching any other duck classes that use flying behaviors. So we get the benefit of reuse without all the baggage that comes along with inheritance. So there are no dumb questions, so let's just read through them. Do I always have to implement my application first, see where things are changing, and then go back to separate and encapsulate those things? Not always. Often, when you are designing an application, you can anticipate those areas that are going to vary and then go ahead and build the flexibility to deal with it in your code. You find that the principles and patterns can be applied at any stage of the development lifecycle. Should we make Duck an interface too? Not in this case. As you'll see once we have got everything hooked together, we do benefit by having duck not be an interface and having specific ducks like Mala duck inheriting common properties and methods. Now that we have removed what varies from duck inheritance, we get the benefits of this structure without problems. It feels a little weird to have a class that's just a behavior. Aren't classes supposed to represent things? Aren't classes supposed to be both state and behavior? In an OO, in an object-oriented system, yes, classes represents things that generally have both state, instance variables, and behavior, which are methods. And in this case, the thing happens to be a behavior. But even a behavior can still have a state and methods. A flying behavior might have instance variables representing the attributes of flying, wing beats per minute, max altitude, speed, etc. behavior. So here's our using our new design, what would you do if you needed to if you needed to add a rocket power flying to the SimUDuck app? So I think what needs to be done is that since we already have a fly, which is an interface, we can directly implement a class that inherits directly from the fly interface, and we can call this rocket powered fly. So when we do that, we are making sure that it also implements the fly method in its own way, and this is separated from our class. Create a rocket powered, create a fly rocket powered class that implements the fly behavior interface. Can you think of a class that might want to use the quack behavior that isn't the duck? Can you think of a class that might want to use the quack behavior that isn't the duck? Hmm. Uh, yeah, I don't really know what this question even means. One example, a duck call a device that makes duck sounds. Well, whatever. So integrating the duck behavior. So now the key is that duck will now delegate its flying and quacking behavior. instead of using quacking and flying methods defined in a duck class or subclass. Here's how. First, we will add two instance variables to the duck class called fly behavior and quack behavior that are declared as an interface type, not a concrete class implementation type. Each duck object will set these variables polymorphically to reference the specific behavior type if we like at runtime, fly with wings, squeak, etc. We'll also remove the fly and quack methods from the duck class and any subclasses because we have moved this behavior out onto fly behavior and quack behavior classes. We'll replace, I think this should be interface here, well, whatever. We'll replace fly and quack in the duck class with two similar methods called perform fly and perform quack. We'll see how they work next. So we have a duck which has a fly behavior, and quack behavior, quack behavior. Behavior variables declared here are declared as the interface type. Instance variable holds a reference to the specific behavior at runtime. These are the methods that we can have: perform quack, perform fly, scream, and display. Now we implement perform quack. Public class dot quack behavior, and then we have public quack perform quack, quack behavior dot quack. Each duck has a reference to something that implements the quack behavior interface. Rather than handling the quack behavior itself, the duck object delegates that behavior to the object referenced by the quack behavior. Pretty simple. Perform the quack, a duck just allows the object that is referenced by quack behavior to quack for it. In this part of the code, we don't care about what kind of object it is. All we care about is that it knows how to quack. More integration. Okay, time to worry about how the fly behavior and quack behavior instance variables are set. Let's take a look at our mallet duck class. So we have a mallet duck that extends the duck, and quack behavior is equals to new quack, fly behavior is equals to new fly with wings. So mallet duck uses the quack class to handle this quack when perform quack is called. The responsibility for quack is delegated to the quack object and we get a real quack. And it uses fly with wings as its fly behavior type. Remember, mallet duck inherits the quack behavior and fly behavior instance variables from class duck. And then we can have a display method saying I am a real mallet duck. So mallet duck quack is a real life duck quack, not a squeak or a mute quack. So what happens here? When mallet duck is instantiated, its constructor initializes the mallet duck inherited quack behavior instance variable to a new instance type quack, a quack behavior concrete implementation class. And the same is true for the duck's flying behavior. The mallet duck constructor initializes the fly behavior instance variable with an instance of type fly with wings. So wait a second. Didn't you say we should not program to an implementation? But why are we what are we doing in that constructor? We are making a new instance of a concrete quack implementation class. Good question. That's exactly what we are doing for now. Later in the book, we'll have more patterns in our toolbox that can help us fix it. Still, notice that while we are setting the behaviors to the concrete class by instantiating a behavior like quack or fly with wings and assigning it to our behavior reference variable, we could easily change that at runtime. So while we have a lot of flexibility here, but we are doing a poor job of initializing the instance variables in a flexible way. But think about it, since the quack behavior instance variable in an interface type, we could, through the magic of polymorphism, dynamically assign a different quack behavior implementation class at runtime. Take a moment and think about how would you implement a duck so that its behavior could change at runtime. Testing duck code. Okay, so let's do some typing now. So we have type our duck class, in which has instance variables as fly behavior and quack behavior. These are both interfaces. Then we have a constructor of a public duck, and we have a abstract void display method, and we have a perform fly, which does the fly behavior of fly and quack and swim. So we can definitely have these interfaces like that, and we can have class fly with wings implements this, fly away implements that, and similarly for quack behavior, we can have that. And then we can have a mini duck simulator, which is a duck new mallet duck that perform fly. MetaDuck will perform that and that. So here we just have a duck, we just have interfaces, Quack behavior interface, and a MetaDuck. This calls the MetaDuck in editor. Setting the dynamic behavior. So let's just type this out first. I think they have an extended MetaDuck here, as we can have here. This is why we have MetaDuck right there. Let's type this out first, and then we'll see what we can do with us. All right. How do I connect my keyboard here? Mhm. Okay. All right. Oh, seems like I have to code on my laptop's keyboard only. So let's do this then. Let's create a new project. Let's call this SimQDoc. Let's do this. Let's just use Maven. All right, we have our POM XML file. We have our main.java. Let's just have some things here. Okay. So let's create a new, first of all, let's just try to create a, all right, let's first create a abstract class for our duck. Let's just call this duck. So this is an abstract class that needs to be implemented. And then we are going to have two other things. First of all, an interface. Let's just go call it fly behavior, uh duck fly behavior. And then we are just going to have another interface. So let's just call it quack duck quack behavior. So these are the two interfaces that we have, and they're going to have some methods. For example, let's just say that it has a method called public abstract. Mm, it's a void method, quack if we say. That needs to be implemented. Similarly, we're going to have a fly method that is an abstract method. So just call this fly. It needs to be implemented. Then we are going to have two instance variables for those. First of all, we're going to have a duck fly behavior, duck fly behavior. Then we're going to have a duck quack behavior. Quack behavior is what we're going to have. Other than that, we're just going to have a public abstract void display method. And other than that, we're just going to have a public void quack method that will inherently be quack behavior dot quack. Similarly, we're going to have a public void fly method that is inherently just going to be dot fly behavior dot fly. So we have delegated this behavior, and then we're just going to have a Java class, another, let's just call it MalletDuck. All right. So before doing this, we need to have some classes that are extending this. So let's just say fly with wings. And then we're just going to have another class called fly no wings. Right here, we're just gonna have another class called fly, no wings. So this implements our fly behavior, and yeah, so we're just going to implement our public void fly not out of println. I cannot fly. Similarly, we're just going to implement here duck fly behavior, and then we're going to have a public void fly system not out of println. I can fly. That is what we're going to have. Similarly, we're just going to have three types of quicks. We're just going to have a quack class. We're going to have a squeak class. Squeak. And then we're going to have a mute quack class. So these classes will obviously implement an interface quack behavior. And then we're going to have our method, which is quack. So it will just say, no, Ellen, I can quack, I can mute quack, something like that. Similarly, we're just going to have our other method that will implement the quack behavior. And this would be just public void quack method, and it will say system.out println I can quack normally. That is what we're gonna have in this method. And then we're just gonna have a squeak method that also implements the quack behavior. We're just gonna have a public void quack method that will just say system.out of println I can squeak but can't quack, something like that. I think we're done with everything. Yeah, so probably now mallet duck, I think, will extend duck class, and then we're going to have a public void display that is going to be out.println I am a mallet duck. And other than that, we're just going to have some quack behavior that is uh, so we're going to have duck quack behavior equals new quack. And what else we're gonna have? We're gonna have duck fly behavior is equals to new fly with wings. And I think we need to make these methods as it should be in the class. So let's just make them public. Let's make this public. And it should be able to implement it. I don't see what's the issue here. Identifier expected. It should be able to implement it directly. I don't know what's problem here. There must be some problem. So we have a duck class right here. We're gonna have a perform fly, perform quack. Swim, we can ignore that. Perform quack, perform fly. We can also have a swim method if we want. but I don't know if we want that. Duck, and then we're gonna have public void swim system dot out dot print ln see me swim. But I'm still not sure how it is public mallet doc it does this. I think it should have been able to do this, but public mallet doc. I don't know why they're not able to identify that. That's an interesting thing. Yeah, I think I implemented these quite correctly. Oh, okay. I think there might have been. Hmm. Yeah, there must be some problem here. Um, Regardless, we were able to solve this, and this should be the quick behavior. Yeah, I think this is fine. Now we can implement this. Remove all this here. All this notation. Let's just have duck mallard duck equals new mallard duck. And we can just have our mallard duck dot perform fly, mallard duck dot perform quack, mallard duck dot swim, mallard duck dot display. Yeah, let's just do it. And I think the command was shift and F10 or something. Let it build. I can fly, I can quack normally. This should be, I think I can normally see me swim. I'm a mallard duck. That's interesting. We were able to do the what we all wanted to do. Cool. So we can run the main class now. Yeah, that's perfect. We were able to implement it. Testing the duck code, we were able to do that. Now we're just going to set the behavior dynamically so that we are able to have a model for our duck and all that stuff. And we can continue this in the next video. So peace out for this one.